Okay, hi folks. Yeah, welcome back to once again the new session of algorithm and programming in C. So, and let's begin our session with the concept. The new concept to understand is algorithms. Okay? So, what is algorithms actually? And these algorithms actually are the finite sequence of instructions. So, whatever instructions and which is a finite sequence, that means you have some finite sequence of instruction that solves a problem. So we might encounter certain kind of problems in programming, like any kind of problems in programming, like finding or sorting or searching the key or sorting the array of integer numbers, or maybe checking if is the number is prime, or checking the number is odd, or checking the number is even. Any kind of this kind of programming problems which can be solved in programmatically, which can be solved. And to solve this kind of problems, we uh, create a finite sequence of instructions in C programming language, and this finite sequence is itself called as a algorithm. All right. So algorithm actually has to receive input values. Okay. So the concept is like it has to receive input values and it has to produce the output values. And this is very required criteria for being an algorithm. That is, it has to receive the input values and it has to produce the output values, and the instructions must be executable and terminate in finite states, right? So they usually work on data structures and must be clear and easily understood. So these algorithms must be easily understood. Okay, it must not be messy, or it must not be something like not understandable or something like this. And usually the concept about the data structure, which is one of the most important concept that we will be dealing much in depth in our coming sessions. Alright, so why do we need this algorithm then? Usually we need this algorithm, as I have already stated, that just to solve a problem, programming problems, right? And not only for programming problems, they are also used most specifically in computers to increase the speed, okay, speed of computation, to increase the speed of computation in computers, or to process more data. Okay, usually your computer is processing some data, right? So you can also create your own algorithm to make the processing very faster. Alright, and to do something extraordinary, that means like solving some problems which are not solved, like for any kind of problems, okay, any kind of programmatic problems which are not solved, you can use the algorithm to solve the problems, that particular problems, to do something extraordinary by solving the problems. Alright, and now you know, you guys will encounter many kind of problems in programming. Okay, so one of them is a decision problem. Decision problem is some problem that is like you have to make a decision, you have to check it either yes or no. So such kind of problems, decidable problems. So for example, one of the decidable problem is the number prime? So you are given a number and you have to find that is the number prime. Okay, so how can we do that? Okay, how can we handle such kind of problems, some decidable problems? I have written a program, simple program here, and it is it's a very easy program. It's like I declare the integer here, I just say enter and check the number prime. Okay, so scan the number, and you call the function that is prime, and inside the prime you pass the parameter that is integer number, and similarly the factor is assigned to value 2, and n modulus factor is equals to 0, then that means the number is prime. If the factor, I mean, it is not divisible like this, then the number is not prime, right? So this is the very easy concept, right? You guys know the basic concept. You have to use the basic fundamental property of that problem. Like for example, if you are asking is the number prime, that means you have to always before creating the algorithm, just have to check out like is the number prime, what is prime, what is the property of prime. Prime are numbers, are those numbers which are divisible by 2, right? So and if it is not divisible by 2, then I just use the simple property that is divisible by 2 or not. Okay, and then I am able to just solve this kind of decidable problems, right? Okay, now check it. Let's check it, and let's let's enter the number that is 7. 7 is not a prime number. It's not a prime number. Okay. And like 2 is a prime number. Yeah, it's a prime number, but it's just something like that. 4 is a prime number. Okay, so the problem here was like I was I have to specifically print the else here, otherwise this is not going to print anything. Okay, so now it is going to work here. See? Yes, it's a prime number. Oh, yes, it's a prime number. 8, yes, it's a prime number. Now whenever you put like 5, no, it's not a prime. That's working well right now. Alright, so with this simple concept, now I will go back and let's see. And what it says is like sometimes the decision problems are not decidable. Okay, so in such a case there are no algorithm to solve such kind of problems. For example, one of the problem is a Turing-Halting problem. Okay, so what you have to do in the Turing-Halting problem is like you have to solve, like just for detailed information about the Turing-Halting problem you can search the web. But what is in the Turing-Halting problem is you are given an algorithm that is A and a data that is D. Okay, so decide whether AD terminates in a finite number of steps. So given the algorithm and data, will the algorithm terminate in a finite number of steps? So you have to decide it. Is it sure that the finite number of steps, like for example if I say that okay it will terminate in 5 steps, no, it's not decidable. Okay, so this kind of problem is called is not undecidable. Okay, so this kind of problems which are undecidable are called undecidable problems. Okay, which are also undecidable. It's not like all the problems are very decidable. Like is the number prime? Yes, we can decide it. But yes, it's a prime. Okay, so even other, right? So similarly, it happens something like that. And usually actually we can subdivide the computation of problems in 3 classes. Okay, and the first class is polynomial problem, that is having like which can have the problems which can be solved in a constant time and which can turn in finite number of steps. Okay, so and exponential problems like which require exponential time to solve the problem, interactable means which are not computable problems. Okay, so usually the problems are of this type. And now let's check out what is the class, that is a polynomial problems. Okay, and for polynomial problems are there those problems where for which there exists an algorithm to solve the problem in constant time, that is it terminates in a finite number of steps. Alright, so and the example of one of the polynomial P-class problems are sort an array of n integers. So when you are sorting an array of integers, what kind of sort algorithm you are using? Like if you are using linear sort, then it will take a linear time. Okay, so it is very constant time, right? So that was the idea. And for NP class, that is non-deterministically polynomial, that means there are some decidable problems for which there are an exponential algorithm but not known. That means some decidable problems have some kind of exponential algorithm, they are not That means it's not like so sure that there will be no algorithm at all. Okay, but there will be algorithm, but it will take some kind of exponential time to solve this kind of problem. So those kind of problems often mistaken. Okay, learning time. Okay, is the key to using in this array. So it is a decidable problem. So how to solve this by using a search algorithm? So the input to solve this algorithm is like the input will be always the array and the key, and the output will always like decide like yes or no. Okay, if yes, then where in the array, which index of that array has that particular key. So these are some kind of problems. So an algorithm one, that is a first algorithm that we use to search such kind of array, such key in the array is like a sequential search. Okay, so here we scan the array from the first element to potentially the last one. That means starting from first to last, that is linearly you scan the whole array one by one. It's like each array, so it has a complexity linear. Okay, linear complexity. That means you are scanning from start to the end, and you compare the key. For each element in the index, you compare the key with them and the current value. So and you may find the key. Okay, so here I have just written the algorithm here, and it says that integer, the return type is an integer, or it can also return the return type must be integer, and because we must return 1 or 0 to specify that it is found or not. So here like linear search, okay, what are the things provided are the parameters provided are the array, and this is the first element, the last element of the array, and the key which you want to search. And first you define the variables that are found in I. The index is equal to the first index is equal to the first element, and while you say that the found is equals to 0, that means found is you haven't found anything. While you haven't found anything, and the OR operator, the logical operators, and I is less than 1, the index is less than the last element. While this index is less than element, so it will cycle until the index is just to the last element. Then you check the condition, that is you decidable problems with the condition say that the array of this index is equals to the key or not. The key is the value. So whenever this array index is equals to the key, then the found is equals to 1, and you increment the value. Alright, so if found equals to 1, so if not found, then again it increments from the difference, it searches for another one. So okay, it keeps on cycling until it finds the key. And lastly we say that if found equals to 1, that means if found, okay, that means you return 1, that means we have found the key. Else you return 0, that means we didn't find the key. Alright, so this is a simple way of generating algorithm, and this was the example of creating algorithm in sequential search. That means sequentially you are searching, or we are doing it linearly, searching whole elements in the array. Now for algorithm, this is second type of algorithm to solve such kind of similar problem of searching the key in the algorithm. And for second type of algorithm is a binary search. So for this binary search, what will be your approach is that you have like at each step we compare with the middle element in the array. Binary means like we are going to divide the array, okay, to just imagine, just think about this, like before I search whole array linearly, it's one by one, okay, for each index one by one I search and compare with the key, and I found the key was like the complexity was linear, right? But for here, for binary search, what the strategy, the approach is like you are dividing the array. That is the division. Okay, you are dividing the array, and you compare. Actually, what you do is you compare to the middle element in the array, and what is like at each step you compare them. Okay, you compare key with the middle element in the array, and we have condition. So if it is equals, then termination is success. That means we found the key. If less than, okay, that means if the key is less than the middle element, and the middle element is less than the key, then we have to the middle element or the key is such less than the middle element, then we have to go towards the right side of the subarray, right? So you have to check in the left side of the subarray. That means if it is less than, I mean, you first divide the array and it will divide into left and right subarray, right? So if the key that you are searching is less than the middle element, that you are first you check the middle element, and if the middle element is okay, that means if is equal to 0, then you are saying that okay, we found the key, okay, and we terminate with success. Then we check it, okay, the middle element doesn't match with the key. Then what we say that we check that is the key less than the middle element. If the key is less than the middle element, then you search on the left side of the subarray. Alright, so we are searching on the left side of the subarray. But if the key is greater than the middle element, that means we have to search for the right side of the subarray, right? So, and this way we just try to optimize. Okay, this is the way of optimizing is, like as I have already told you before, that algorithm is mostly used to do the data computation very faster, right? So like before we have to search linearly, means each time, but right now we are searching it half, like it's taking half of the time, right? So that was the idea. Okay, now for the binary search, the algorithm that I have provided here is like, here is the binary search, and the parameters provided are the array, the first element, the first element and the last element is A and B, and also the key, alright. So int C is for the middle element, and you declare a variable for the middle element is C, and also declare found, that is 0. So you also say that while A is less than B, I mean A is less than B means it has to go until A will be equals to the A is the first element is equals to the last element. I mean if A is greater than B, that means the first element is greater than the last element, then it is going to collapse itself and there is no cycle blocker. So here first immediately we divide, we get the midpoint, we divide the array into and grab the mid element. What we say is like C equals to A plus B, the first plus the last element divided by 2, and if the array of that index, the middle element index, is equal to the key, so that means that if the middle element is equal to the key, then we found is equal to 1 immediately, and we return the C. Alright, else we have to shift. Either you have to go to the right side of the subarray or to the left side of the subarray. So here what we have to check is if the middle element is less than the if the middle element is not the this is not the this is actually it must be something like, if this middle element is less than the key, alright, if the middle element is less than the key, that means array C is the middle index, so middle element is less than key, then if is less than key, so what happens if the middle element is less than key? We have to go to the right side of the subarray. So how do we go to the right side of the subarray? To go to the right side of the subarray, what you have to do is like we have to say that the first element will start from the middle element. So here is a difference. First element here will start from C minus 1. It's not C minus, C plus, first element will start from C plus 1. Okay, that is C is the middle element and plus 1 is the middle element. Whereas then we have to say that we have to start from we have to go to the left side of subarray, and for to go to the left side of the subarray, your first element will be always first, but your last element will be the middle element. That will be this middle element minus 1. Why I did minus 1? Because C minus, if I put C, then it is also going to check C, but C we are already checking C, the middle element here. We can check out if the middle element equals to 2. So we have to check 1 less than the middle element. Alright, and this is the way how it is done. And lastly we return 1. And this was the algorithm for binary search. Alright, similarly you can generate your own algorithm. Okay, and it depends on the programmer itself of what kind of algorithms you want to create. This was the optimization of the sequential search. Okay, right now for the sorting algorithm, here to sort, we have to what I'm using sorting. What is sorting? First, sorting is usually we are provided with the array of numbers, integer numbers, and what will be the output? What is the output we have to generate? It's like we have to generate the numbers, the same number, which have some relational order. Okay, there is some kind of relation, and that means what kind of relations that order relation that holds. Like for example, the first element is less than the less than the second element, and second element is less than the third element, third element is less than the fourth element, and similarly goes to the last element. This relation holds, then this is sorted, right, in ascending order. Okay, and more specifically you have to understand. Now what is the approach? The approach is like the data input with integer in array A is provided, right, and then what you have to do is you have to partition array partition into subarrays. That means you have to divide the array into parts, like left or side, sorted or unsorted. Then on each step we expand the sorted subarray by inserting one more element. That means the basic concept is like first among all the array we divide into left and right subarray. So actually in the beginning what happens is like the left subarray is just only one element. Okay, and what we do is in an incremental order. Okay, so it increases. So on each step you are going to add one more element which is just greater than that element. Okay, one more element. So you just expand the array immediately. Okay, first one, the left subarray consists of only one element which is sorted, and then on each step you expand the sorted subarray by inserting more elements. Okay, so more and more elements are added there, and after all the elements sorted in a proper order, like after all you get in the end result you will get all the elements that are sorted in a proper order, and you will return it. Right, so let's see the algorithm. So what's the algorithm? So the algorithm will be something like you provide the array and the size of the array, that is the integer number, and like you have the index here ijx, and for each looping you say that 1 is 1, then if I is less than the index is less than the size, then you increment the counter, and now you say that the x means what? X means something like it's a variable, and if variable equals to array, the index, the first index, that means x is a buffer. It's like something like a temporary variable, that this temporary variable consists of the first element of the array, that is the index I. Okay, so index I. So firstly this buffer, okay, this temporary variable will has a first array element, right, and then j is an index that is equals to I minus 1. Okay, so now j would be something like, if the index starts from 1, then the j will be 0. J is 1 less than the first element. Now why in the second condition what you say that j is greater than or equals to 0. Okay, so what happens is like j is greater than or equals to 0. Yes, you can easily say that this j is greater than or equals to 0, because when index is 1, j is greater than or equal to 0, and this is the logical operator, and x is less than array. So x is the temporary variable that consists of the first element index I. So this is the first element index I is less than array j. So array j is actually index 0. So that means the firstmost element, right? So you know that the array starts from 0 element. So actually what it does is compare two elements, that is the first and the second element. It compares of the array. They compare together, alright? So they compare each other, and what happens, like if the first element is less than the, I mean if the second element is less than the first element, then the second element, okay, in the place of the second element you will have a first element, or yeah, you will have a first element, because you know that the first element, after checking, the first element is less than the second element. Okay, so first element is less than, I mean second element, when you check that the second element is less than the first element, then you have to switch the first element position to the second element, so that you just avoid the condition that like to make just the relation holds, right? To make the sorting relation hold, right? For that context, you are just first checking the two elements, first and the second element, and if the first element is greater than the second element, you just switch them, right? You just switch the position of the first element with the second element by using a temporary variable index. Alright, so the index that I am using, the temporary index I am using is j, and the main index is I, right? And the temporary variable where the value of the array exists is x. And I just decrement the temporary index, that is j minus minus. Immediately after switching, I just decrement the index. So index will be just 0 and 1. It is 2 index for j. Alright. And lastly, if this condition doesn't hold, that is x is the first element is not greater than the second element, then immediately you just put, okay, it's not greater, so just put x, put the same array in different position. Alright. So this is how you do the sorting algorithm. And with this concept, I just want to close this session, because we have no more no more things to discuss in this session. So we just discuss something like some basic algorithm. It was to search and sorting. Okay, two searching algorithms and one sorting algorithm. That was binary search and linear search and the insertion search. So this was the for the session of today, and we'll be discussing much more in the later session. And just keep on listening, and thank you.